Hello everyone and welcome to this video. So today we are going to be learning how to choose the right machine learning model to suit our problems in Scikit-Learn. So as you can see, there is this confusing mind map. We're going to be using this today to solve our problems and help us choose a machine learning model. So don't worry about this, you'll understand it in this video. So let's start. So here we are. This is where we left off last time. So what we did last time is we learned how to fill up missing values with Scikit-Learn, and then the previous video before that we learned how to do it with pandas. Okay, so we learned how to fill in missing values, and we also tested it. So the score didn't come so well. So that is why I thought we could learn how to choose a machine learning model. So at the start of this whole section, we created a list called what we're covering. So we're going to view that. So we're going to do number 2 in these next 3 videos, including this one. So we're going to do number 2. So we're going to choose the right estimator. So in Scikit-Learn, it's usually known as the estimator. But it's actually just a model for our problem. So I'm going to choose the right one. So what I'm going to do is I'm going to turn this into a markdown cell. And in the heading, I'm going to write choosing. Actually, this is number 2, isn't it? Let me just quickly do something. Yeah, so I just want to check if all the others were numbers. So this is number 2. So number 2 is choosing the right estimator or model. So let's put that in brackets for our problems. Okay, so we're just gonna put a little thing here. So we're just gonna write Scikit-Learn uses estimator as another term for a machine learning model or algorithm. So algorithm is usually used in coding. So you'll usually hear estimator today. So today we're going to be looking at a few documentations. So you will see estimator being used in the Scikit-Learn documentations. So now let's actually list the different problems the 2 problems we're going to focus on in this sort of section. So the first problem we're going to focus on is classification, or actually the first one we're going to focus on today is regression. So regression is basically predicting a number. So if you had x and y as your data, the x would be the features, and then the y would be the target. So we're trying to predict the y, which if we were trying to find a model for regression, our y would be a number that we want to predict, whether it's a car price or a house price or anything like that. And then the second one we're going to focus on is classification. Okay, so classification is predicting whether a sample is one thing or another. Okay, so basically classifying which one is right, which one is wrong. So we'll be seeing a classification chart today that will help us predict the models. Okay, and what I meant by classification is, like, let's say for our heart disease data set, the new one, the one we used in this series, it had a 0. The target was either 0 or 1. So it's either one thing or another thing. So that's classification. It's either yes or no. It's either right or wrong. Some stuff like that. Okay. So So the first thing is we're going to write down step 1 to this. So step 1 is to check out the Scikit-Learn machine learning map. Okay, so let's press enter, and in a new tab, but actually first, before we do that, let's just put a mini subheading here. So we are going to be putting 2.1, which is picking a machine learning model for a regression problem. Okay, so that's the first type of problem we're going to be looking at today, and I spelled picking wrong. Amazing. There we go. So we spelled that right now. So what we're going to do is we are going to open a new tab, and what I'm going to type in is Scikit-Learn machine learning map. Okay, so if we type that in, you should see choosing the right estimator. So remember, estimator means model, so this is what we must be looking for. Okay, so here we go. Here is our beautiful map. So first I'm just actually gonna copy this link, and I'm gonna pop this link up here so that we can keep it there if you want a reference to it. So here you can see a confusing mind map. Okay, so you probably saw this at the very start of the video. Very confusing mind map. So here it has different sections like classification, regression, dimensionality, reduction, and clustering. So today we're going to be focusing on regression today. Okay, so we're going to just push these two out of the way, and we're going to focus on regression, and then next video we're going to focus on classification. Okay, so there would be a start here, and then there'd be these different sort of situations, and if the arrow that says yes, so if you are in that situation, you go to the yes way. If it's not, then the no way. Okay, so this is what's called a classification chart. So back to here, what we're going to do is basically Scikit-Learn has a data set called the Boston housing data set. So Boston is a city in America, and there is a data set called the Boston housing data set. So what we're going to do is we're going to import it. So import Boston housing data set. Actually, I don't think housing should be capital. There you go. So what we're going to do is we're going to say from sklearn dot datasets import load Boston. Okay, and then after we've done that, we're going to have to go Boston is equal to load Boston. After we've done that, we are going to view our Boston dataset. So as you can see here, it is a very confusing set of numbers. So because that takes up a lot of space, we're going to put a semicolon there. And actually, let me just show you something. So this actually appears to be a Python dictionary, and it has different keys such as data, that's one key, target, that's one key, feature names, that is another key. Okay, so let's just put the semicolon there again. So what we're going to do is we're going to turn this into a data frame, because pandas is perfect for that, and pandas, when you have a pandas data frame, it is going to be much more easier to visualize. So we're going to go Boston df, or data frame, df is much shorter, is equal to pd dot data frame, frame, there we go, pd dot data frame, and then so let's just press shift tab to see what we need to include. So what we need to do is we need to put the index and the columns. So the index, it doesn't really matter. Okay, so what we're just going to do is we're going to put in Boston data. Okay, so Boston data, so that we're going to put in the data key. So if we just take away the semicolon, so our data key is just this large array. So that will basically be our index, okay? So that's the index, and then we've got columns is equal to Boston, and then I showed you the feature names key, okay? And then we're just gonna say Boston DF target, so we're gonna create a target column for us, is equal to pd dot series, so just going to be adding another column sort of, is equal to Boston, and then as I showed you, there was a key called target, so that's the target we're working towards. And then we're going to view Boston DF. Whoa, okay, it says PF. There we go. So you can see it says Crim, ZN, Indus, Chaz, Nox, RMH, and all of this confusing stuff. So to break it down a bit, we're just gonna type in Scikit-Learn Boston dataset. Okay? So we're going to go to sklearn.datasets.load Boston because that's what we did. So if we go down here, we can actually see this, and then so we can actually sort of see the returns and everything, but this isn't the page we actually want. So we're going to read more in the user guide. So if we go to the user guide, here are the attributes and information in order. So these are the attributes in our data. Let's just close this. Let's just close this one actually. So here are all of the attributes that are here. So Crim is per capita crime rate by town. So this is the crime rate for each town. And then this is the proportion of residential land zoned for lots over 25,000 square feet. So that's said N. And then we have got tax, PT ratio, pupil teacher ratio, and things like that. Okay, and so that is what it is, and the target is basically just like the sort of cost we're working towards. So let's close that. So not this, the page that we just looked at before. So now it is time to start testing our data sets. So we're just going to click this link. That's why I put it there. So if we just come here. So what you're going to do is when you're using this mind map or classification chart, you want to start at the start bit. So let's go here. So we're going to start by start. Go to here. So do we have more than 50 samples? If that's no, then we have to get more data. If that's yes, we can move on to the next one. So let's just check if we have enough samples. So we'll just have a question, say how many samples. Okay, so how are we going to actually check this? Is that a W there? There we go. Yeah, that is a W. So if let's just check how many samples. So we're going to go length of Boston DF. So 506, that is enough. So that's definitely more. Predicting a category. So a category is basically like when you're predicting a category that is in classification, but we're we're looking at regression right now. So no, that's certainly not. We're doing numbers, not categorical values. Predicting a quantity, yes, because yes, it's numbers. Do we have less than 100k samples? Amazing, yes we do. A few features should be important. What could that mean? So we don't want to take the risk, okay? So we're going to go for no. So the first thing we're going to go to is ridge regression, or SVR kernel equals linear. Ridge regression, let's just click on ridge regression, okay? So it sends us to here, okay? So ridge regression addresses some of the problems of ordinary least squares by imposing a penalty on the size of coefficients. Oh my goodness, so that is a lot. So ridge regression is basically a model for regression. Okay, so this is the code. So it says from Scikit-Learn import linear model. Reg is equal to linear model.ridge. No, we're not going to do that actually. So we're going to go, what we're going to do is we're going to style it to our taste. So what we're going to do is we're going to just put a comment. So let's try the ridge regression model. So what we're going to do is we are going to say from Scikit-Learn dot linear model. So instead of having to say from Scikit-Learn import linear model and then having to say linear model.ridge, you're just going to say from Scikit-Learn dot linear model import ridge. Much easier. So after we've done that, we are going to set a random seed. So set up a random seed. So np.random.seed. We're going to set it to 42 as we always do. And then what we're going to do is we're going to do a very simple step, and very important step too, is to create the data. So we have done this a lot of times now. So x is equal to Boston df dot drop. So we're going to drop our target column because that is our target. We do not want to put that in our features matrix. So target axis is equal to 1. So target column now, not a target row, because there is no target row. And then the y is equal to Boston df target, because we only want that one. And then what we're going to do is we're going to split it into train and test sets. So we do this using train test split. We don't need to import it because we've already imported it a lot of times. So we're going to say x train, x test, y train, and y test is equal to train test split. So you've got x data, y data, and then we're going to pass in the test size, which is going to be 20% of the whole data set itself. So now what we're going to do is we are going to instantiate the ridge model. So what I mean by that is, let me just write this down. So instantiate the ridge model. So what I mean by that is we're going to sort of just make it in, actually make the model, and then we're just going to fit it to data. That's all we're going to do for instantiating it. So we're going to say model is equal to ridge brackets, and then we're going to say model.fit x train and y train. And now we're going to write some more code is to check out the actually we're not going to write it like that. We're going to write check the score of the ridge model on test data. So how well has it done? So this is easy. Model.score, and then we're gonna pass in X test and Y test. So this is the moment of truth. We're gonna run it. Okay, that is not so bad, but what I am thinking is, could we improve this score? So there should be enough space for improving this score. So that is either to give it either to improve the data set or train it more. But the only solution we really have right now is basically just the only solution we have is actually just giving a different data set, different model. So using a different model. So in Markdown here, I'm going to write, how do we improve this score? What if Ridge wasn't working? So what if it wasn't working? I'm just going to also just put I'm just also going to put a reference to a mind map. Let's refer back to the map. Whoa, what did I type here? Let's refer back to the map. Sorry about any inconvenience. So yeah, there we go. So how do you improve a score? What if Ridge wasn't working? So those are the questions we should be thinking about. So we're gonna go to our map, back here again. So we're gonna go back to regression. So here in this ridge regression place, there is an arrow saying not working. So that means if it's not working or if you want to improve your score. So the first one it's pointing to is Ensemble Regressors. So we're going to point to that one. We're going to go to that one. So if we go down here, it says forests of randomized trees. Does this seem familiar to you? If it does, well, let's go down here. It says random forest classifier and random forest regressor. We have been using that for we've been using this for the whole series, for this whole Scikit-Learn bit. So now we're going to use that and see if our score improves. So this is what we want to do. We're going to want to go instead. We're going to actually want to go. If we just press random forest regressor, there should be some code down here. So from Scikit-Learn.ensemble import random forest regressor. So we've already used this, so it should be quite familiar. It should be very familiar. So actually, all we need to do is just need to copy exactly the same code. Okay, so saves a lot of time. So we're going to, so we're not going to try the random regression model. We're not going to try the ridge regression. We're going to try random forest regressor. Okay. So we're going to write from Scikit-Learn.ensemble import random forest regressor. So we're still working with the Boston thing, and so we want to change this ridge over here to random forest regressor, and we're actually going to call this RF, so we know that it's the random forest. So RF, and I'm just going to change this over here, random forest regressor, and here is here we're just gonna write random forest regressor. Okay, so now let's just see if it is if it works much better. Yeah, so it actually does work much better because random forest regressor is actually really good with pandas data frames, so predicting from pandas data frames. So that's why it could have worked better. So let's actually just check the ridge model again so we can actually see them side by side. So I'm going to say model.score. That's why I kept them different. So we're going to put X test and Y test. Okay. So yeah, you can see that because we choose a different model, and we actually sort of, where is the map? Let me just go to map. There we go. So because we choose a different model by going through a not working arrow, we found ourselves a much better score than before. It's actually quite a lot. So so this is today's video. In the next video, we're going to learn how to choose an estimator for a classification problem. Okay, so that is when you are choosing from only two sort of answers. Okay, so two targets. So it's either one or the other. That's a classification problem. Okay, so if you like this video, please like and subscribe. I'll leave the link to the site, this Scikit-Learn site, so you can just access it if you want, and just look at it for a bit. You can try making your own classification. You can try making your own classification. You can try it yourself. So try to do the next step yourself. If you can't, that's fine, because you can just watch the next video. So if you like this video, please like and subscribe. That would really help. And if you have any doubts, please comment them in the comment section below and I will help you. I'll try as best as I can to answer those. And yeah, so please look out for my next video, and I guess this is it. Bye.